Battery technology for EVs is always evolving and never really stops improving. But when it comes to Tesla's 4680 battery, it looks like it may have already reached its peak. Simply put, it's hit a new high with major breakthroughs delivering maximum energy output while cutting mass production costs by as much as 50%. Thanks to these improvements, Tesla has confirmed that the 4680 battery will be used in the Model Y going forward, and a super long-range version could be launched very soon. This is honestly a huge turning point because, as you probably know, the 4680 battery has only been used in the Cybertruck for the past 2 years, and that truck definitely isn't cheap. Because of that, many people, even industry experts, started to believe that the 4680 battery technology was a complete failure. CATL's CEO Robin Zung even said at one point that the 4680 battery would never work. But honestly, that claim feels pretty ironic because up to now, CATL still hasn't produced a battery that's better than Tesla's 4680. It remains one of the best batteries in the world today. And with the latest upgrades, it's been pushed to an entirely new level, one that could take CATL many more years to catch up to. So let's dive into the latest updates on the 4680 battery and why it might be considered the holy grail of batteries, at least until solid-state batteries truly go mainstream. Tesla first publicly unveiled the 4680 battery at Battery Day in September 2020, when Elon Musk called it the biggest leap forward in lithium-ion battery technology ever. From the very beginning, Tesla wasn't just talking about a new battery cell. It was talking about a complete overhaul of how batteries are designed, manufactured, and integrated into electric vehicles. The name 4680 comes from the physical size of the battery cell, 46 millimeters in diameter and 80 millimeters tall, significantly larger than the 2170 cells that were widely used at the time. But the real breakthrough wasn't the size, it was the completely different design philosophy behind it. So what exactly makes the 4680 battery so special compared to a regular lithium-ion battery? First, we need to clear something up. The 4680 is still very much a lithium battery. Some people think it doesn't use lithium at all, but that's just not true. It still contains lithium, and it even uses nickel and cobalt. What really sets it apart from traditional lithium-ion batteries is its tabless design. You've probably heard about this already, but not everyone fully understands what it means. In a conventional battery cell, there are small metal tabs that connect the electrodes to the terminals. Those tabs become bottlenecks for electrical resistance and heat buildup. Tesla completely eliminated that design, allowing current to flow more evenly across the entire surface of the electrode. The result: less heat, higher power output, faster charging, and improved durability. On top of that, the internal structure is more efficient, which reduces unnecessary materials and leads to higher energy density. The last time we heard official numbers, the 4680 battery had an energy density of around 272 watt-hours per kilogram, and it doesn't seem like that number has changed much since then, at least not publicly. There haven't been any reports of even minor upgrades. But here's the thing. Even at 272 watt-hours per kilogram, the Tesla 4680 cells are still considered among the highest energy density batteries in the world that are mass-produced. Simply increasing the cell size alone allowed Tesla to drastically reduce the number of cells needed in each battery pack. That means fewer wires, fewer welds, and much lower assembly costs. Tesla began producing its first 4680 cells in late 2021 at its pilot facility on Cato Road in California. But this wasn't full-scale commercial production yet. It was a pilot line where Tesla was both manufacturing and learning how to manufacture at the same time. Those early cells were mainly used for internal testing, evaluating durability, energy density, fast charging capability, and especially how stable the cells were when integrated directly into the vehicle's structure. This testing phase lasted nearly 2 years, and it wasn't until 2023 that Tesla finally started deploying the 4680 battery in the Cybertruck. Okay, on the surface, this all sounds like a smooth journey from research to production to real-world use. But in reality, the 4680 battery hasn't been nearly as perfect as many people expected. That's exactly why it spent years being used only in the Cybertruck, why costs stayed relatively high, and why production ramped up so slowly. We mean, if a battery is truly that good, it should be showing up across multiple Tesla models, right? The truth is, from 2020 to 2023, Tesla's 4680 battery only used a dry anode while the cathode was still made using the traditional wet process. This essentially created a hybrid version of the battery far from Elon Musk's original vision. Tesla simply couldn't fully master the dry process cathode, which is the most complex and expensive part of the 4680 battery. Because of that, Tesla was forced to keep massive drying ovens and toxic solvent handling systems in place. In the end, that wiped out many of the promised advantages in terms of factory footprint and cost reduction. This technical bottleneck caused the earliest batches of 4680 cells to have lower energy density than the older 2170 cells, pushing Tesla straight into what many would call a production hell. Reports showed that early on the battery materials were prone to cracking, had poor adhesion, low yields, and high defect rates, driving real-world costs far beyond initial expectations. Elon Musk himself admitted that scaling dry-electrode technology was much harder than expected, and that even a tiny deviation could break the entire production line. That's why many experts and even Cattle's CEO publicly claimed that the 4680 battery was an unrecoverable failure. Given all of that, Tesla had little choice but to use the Cybertruck as a real-world testing ground for the 4680 battery. The Cybertruck has a completely new vehicle architecture, a large and heavy body, a high price point, and enough margin to absorb the cost of an unoptimized battery. On top of that, Cybertruck production didn't need to be massive in the early stages, which allowed Tesla to manage risk if the battery ran into problems. By contrast, high-volume models like the Model 3 and Model Y simply couldn't afford to adopt an unstable battery technology. Even a small issue could affect hundreds of thousands of vehicles per year, and that's a risk Tesla wasn't willing to take. Because of all that, for nearly 2 years, the 4680 battery was almost exclusively associated with the Cybertruck. That created the impression that this technology had either failed or hit a dead end. However, the latest updates suggest that Tesla has finally solved its biggest bottleneck, the dry electrode process for both the anode and the cathode. In its Q4 update and fiscal year 2025 report, Tesla stated that it is now producing 4680 battery cells, with both electrodes manufactured using the dry electrode process. And Elon Musk has since confirmed on X that making the dry electrode process work at scale, which is a major breakthrough in lithium battery production technology, was incredibly difficult. Congratulations to the Tesla engineering, production, and supply chain teams and our strategic partner suppliers for this excellent achievement. The disclosure was highlighted on X by Bone Eggleston, Tesla's vice president of 4680 batteries, who wrote that both electrodes use our dry process. Previously, Tesla could only apply parts of this process, or it had to fall back on the traditional wet electrode method at certain stages, basically wiping out most of the cost advantages. Now, with toxic solvents completely eliminated, Tesla no longer needs massive energy-hungry drying ovens that take up huge amounts of factory space. According to internal estimates, factory floor space can be reduced by up to 90%, while energy consumption per battery cell drops significantly. This is the key reason why, for the first time, the 4680 battery is actually cheaper than the 2170 on a per kilowatt-hour basis when produced in the US. Beyond cost, these upgrades also have a direct impact on energy density. Thanks to the dry electrode process, Tesla can use an extremely low amount of binder, only about 1 to 1.25% compared to 3 to 5% in conventional lithium-ion batteries. Less binder means more room for active materials that actually store energy. As a result, the energy density of the 4680 cell improves by an additional 5 to 10%, not because of a brand new battery chemistry, but because of better physical structure and material optimization. This type of improvement is far more sustainable, lower risk, and easier to scale than racing toward unproven battery chemistries. Another major upgrade shows up in durability and lifespan. In wet electrode manufacturing, solvents and high-temperature drying can damage the microstructure of material particles, especially on the cathode side. The dry electrode process helps preserve particle shape and bonding, reducing cracking over time. Test data suggests that the new generation 4680 cells can retain around 90% of their capacity after 2,000 charge cycles, which is an extremely impressive figure for long-range EV batteries. This not only extends vehicle lifespan, but also significantly increases the battery's value for second-life applications like grid-scale energy storage. On the cell design side, Tesla continues to refine its tabless structure, which has always been a major advantage of the 4680 battery. With current distributed more evenly, heat generation during charging and discharging is significantly reduced. In the upgraded version, Tesla further improved axial heat dissipation, allowing the cell to handle higher currents without increasing its size or adding more complex cooling systems. This opens the door to more stable fast charging, especially critical for long-range vehicles and heavy-duty electric trucks. Another area that doesn't get much attention but is absolutely crucial is manufacturability at scale. With dry electrodes, Tesla can build microfactories, smaller battery plants with extremely high throughput. Instead of pouring billions of dollars into a single massive gigafactory, Tesla can replicate many smaller production lines, each delivering far higher output than before. According to Elon Musk, at optimal scale, throughput could be as much as 10 times higher, while total battery costs could drop by 20 to 50% depending on the application. This is an advantage that competitors are unlikely to catch up with in the short term, because most of them are still locked into traditional wet electrode manufacturing processes. But that's not all. Another important piece of information is that Tesla has also confirmed it will use this battery for the Model Y. Very few people actually know that the Model Y was already equipped with 4680 batteries 3 years ago, and it failed to create the impact everyone expected. In the end, those versions were discontinued. So why is Tesla returning to the 4680 battery for the Model Y? Tesla's decision to bring the 4680 battery back to the Model Y is not random, nor is it simply a matter of the technology is finally ready. Behind this move lies a long chain of strategic commercial and geopolitical shifts, reflecting how Tesla is adapting to an increasingly unstable global battery supply chain. At Battery Day on September 2020, Elon Musk promised that the 4680 battery would cut battery costs in half, significantly increase energy density, and serve as the foundation for a Tesla priced around $25,000. At the time, the 4680 was not just a new battery cell, it was the centerpiece of a long-term strategy: structural battery packs, dry-electrode technology, high-speed manufacturing, and next-generation battery factories. Expectations were so high that Elon himself later admitted Battery Day had set too many goals at once. The first major turning point came in April 20, 2022, when the first Model Y vehicles produced at Gigafactory, Texas using 4680 cells and a structural battery pack began delivery, but only to Tesla employees. This was a real-world testing phase where Tesla accepted risk in exchange for data. By December 20, 2022, Tesla announced that 4680 battery production had reached 868,000 cells per week, enough for roughly 1,000 Model Y vehicles. On paper, this was a major milestone signaling that the technology had moved beyond the lab. However, reality was far more complex. It wasn't until April 20, 2023 that Tesla officially launched the Model Y AWD, priced at $49,990 with 4680 batteries for the general public. Before that, the model existed as an off-menu product sold in limited quantities with little to no promotion. This suggested that Tesla was not yet fully confident in scaling 4680 battery production, especially when compared to the far more mature and stable 2170 and LFP batteries. Then in September 20, 2023, Tesla quietly stopped producing the Model Y AWD, with 4680 batteries, removing it entirely from the online configurator. At the time, the most common theory was that Tesla needed to allocate its limited 4680 battery supply to the Cybertruck, an upcoming model designed around this cell format. That theory was quickly reinforced when Tesla began delivering the Cybertruck in November 20, 2023, and for a period of time the Cybertruck became the only vehicle using the 4680 battery. But things did not turn out the way Tesla had hoped. During 2024-2025, the Cybertruck proved to be a commercial failure. High prices, demand far below expectations, and production that fell short of targets. This meant demand for 4680 batteries dropped sharply, while Tesla's production capability had improved compared to earlier years. Many people believe this is the main reason Tesla returned the 4680 battery to the Model Y, simply because there was an oversupply of 4680 cells. But that explanation is too simplistic and incomplete. In reality, Tesla clearly explained in its financial reports that bringing the 4680 battery back to the Model Y was intended to diversify the supply chain as a precaution against trade barriers and tariff risks. Put bluntly, Tesla is preparing for a scenario in which Chinese batteries, especially those from cattle, are hit with high tariffs or export restrictions to the United States. Against the backdrop of escalating US-China trade tensions, this is no longer a far-fetched hypothesis. You may not realize this, but today, a large portion of Model Y vehicles sold in the US still rely on batteries from external suppliers, including China. These battery cells are very cheap and extremely reliable, but they come with political risk. If new tariffs are imposed or localization requirements become stricter, Tesla's cost advantage could evaporate overnight. In that context, the 4680 battery produced entirely domestically becomes a strategic shield. The key point to emphasize is that Tesla is not bringing the 4680 battery back to the Model Y because it is the cheapest option, but because it is good enough, affordable enough, and most importantly, under Tesla's direct control. With the dry electrode process largely resolved, the cost of the 4680 battery has now approached, and in some cases even fallen below that of US-made 2170 cells. When tariffs and domestic incentives are factored in, the 4680 becomes extremely attractive from a strategic standpoint. This same logic opens the door for future Tesla models to also use the 4680 battery. Not because the 4680 is a premium battery, but because it allows Tesla to fully control the entire value chain from battery cells to packs, and even the vehicle structure itself. With microfactories and dry-electrode technology, Tesla can place battery plants right next to vehicle factories, cutting logistics costs and responding more quickly to market volatility. The paradox here is that the 4680 battery was once promoted as the pathway to a $25,000 Tesla. Yet Tesla's return to using it in the Model Y is not about immediately lowering vehicle prices, it's about reducing long-term risk. In an ideal world, Tesla would simply choose the cheapest battery available on the global market. But in the real world, where politics, tariffs, and supply chains are increasingly unstable, the battery you produce yourself becomes the cheapest battery in the long run. That's why, in our view, the return of the 4680 battery in the Model Y does not look like a step backward, nor is it a stopgap solution for the Cybertruck. It signals that Tesla has moved the 4680 from an experimental role into a strategic one. And once that happens, not only the Model Y, but future lower-priced Tesla vehicles may also be built around this same battery platform. At this point, Tesla's broader strategy is becoming clearer than ever. The company's plans to scale back or even potentially end production of the Model S and Model X suggest that Tesla no longer wants to spread its resources across low-volume models. In the near future, the Model Y and Model 3 will likely account for nearly all global sales, becoming Tesla's true pillars. Even more notably, Tesla has confirmed that it has no plans to launch a new vehicle, no additional traditional pickup variant beyond the Cybertruck, and no entirely new vehicle lineup coming anytime soon. This may sound surprising, but it aligns perfectly with Tesla's current philosophy of optimization and focus. Okay. In that context, the 4680 battery emerges as a key strategic piece, especially for long-range vehicles in the US market. Tesla is clearly concentrating its efforts on deploying this battery in its best-selling models, not to showcase technology, but to reduce supply chain risk and increase self-reliance. Will this strategy be applied in Europe or China? Most likely not. In those markets, Tesla does not face battery-related tariffs, and locally produced battery cells are simply too cheap. Manufacturing 4680 batteries in the US and then shipping them around the world just doesn't make economic sense. Personally, we're very curious to see whether we're about to witness versions of the Model Y or Model 3 with significantly longer driving range in the near future. What about you? Let us know your thoughts in the comments.